Alright, so we're still on section 10.4. There's one last topic that we need to talk about, and that is tangent lines at the pole. Okay? So, tangent lines at the pole. If f of theta equals to 0 and f prime of theta does not equal to 0, the line theta equals alpha is the tangent line. It's very simple. If you can take your function, you set it equal to 0, you find out all the angles in which it's 0, okay? Then you take the derivative of that function, and if at those angles it is not equal to 0, then there's going to be a tangent line at that angle, okay? So let's talk about it. So let's find all tangent lines at the pole. Okay, so very specifically, at the pole. R equals 2 cosine of 3 theta. Sketch this out so that you have an idea of what you're looking at. What am I looking at here? What should you be looking to graph? This is a rose. Very specifically, a rose with how many petals? A rose with 3 petals, and each petal is going to be of length 2, right? Now, you don't have to get very intricate about your sketches, guys. Like, it's just a sketch. You don't have to be perfect, okay? So, here's what I would do. So, I know that this is cosine, and if I remember from pre-cal, there's going to be symmetry with the polar axis, right? But here we go. I'm going to kind of figure out where the first or one of the petals is located by setting this equal to 2, right? So then 2 equals to 2 cosine 3 theta. If I divide by 2, that means that 1 equals to cosine 3 theta, right? Which means that where is cosine 1? At 0 radians, right? So 3 theta equals 0 plus 2 pi n. So theta equals to 2 pi n over 3, right? So if you plug in integers, you know that your angles or your petals will be located at 0, at 2 pi over 3, and at 4 pi over 3, right? You plug in 0, you get 0. You plug in 1, you get 2 pi over 3. You plug in 2, you get 4 pi over 3. Cool? Now, here's my sketch. 0 radians would be about right here, and I need to go 2 units out, so there it is. 2 pi over 3 should be maybe somewhere up here. There it is. 4 pi over 3 somewhere up here, right? Doesn't have to be exact. Here's my petal. Here's my other petal. And here's my third petal. Cool? Alright, now that I have a sketch, now I'm going to finally go ahead and do the calculus component of this, which is I'm trying to find out if there's tangent lines at the pole. Looking at this, I could kind of see them happening. Here's what I mean, like maybe I could have a line here. You guys see that? Where it's going to go through the pole, and maybe I can have one here. So, but I can't guess, so I need to figure this out. So it says, to find the tangent lines at the pole, you need to do what first? Set your function equal to 0. So what is your function? So in this case, it's 2 cosine 3 theta. So 2 cosine 3 theta equals to 0. Okay? We're going to say 2 cosine, so cosine of 3 theta equals to 0. So where on the unit circle is cosine 0? Pi over 2, and so then that means that 3 theta equals to pi over 2 plus 2 pi n, or 3 theta equals to 3 pi over 2 plus 2 pi n. Agreed? Alright, therefore, if we divide by 3, theta equals pi over 2 divided by 3 is going to be pi over 6. So pi over 6 plus um, 2 pi n divided by 3, so 6 pi n divided by 6, right? No, I'm getting this 4 pi n, I'm sorry. 4 pi n divided by 6, I'm sorry. Or theta equals to 3 pi over 6 plus 4 pi n over 6. Agreed? You could simplify that, honestly. I should have done that. So that means that these are possibilities. We're still not sure if they are, okay? We could have one at pi over 6. We can have one at 5 pi over 6, right? If I plug in, that's 4 times 2, that's 8, plus 1, that's 9. So 9 pi over 6. And then after that, I'm going to go over. Agreed? Or I could also have one at 3 pi over 6, 7 pi over 6, or 11 pi over 6. Agreed? Now, I'm going to kind of simplify things out so that 9 pi over 6 is the same thing as 3 pi over 2. And then 3 pi over 6 is the same thing as pi over 2. 7 pi over 6. And then 11 pi over 6. So when I look at this, you're trying to tell me that I would have 6 different lines, right? That's basically what I'm getting here, that I should have 6 different tangent lines at the pole. You guys with me? Now, remember that in polar, when it's just theta equals an angle, that's just a line at that angle, right? So let's kind of talk about this. Let's pretend that I'm going to grab this one out. So this pi over 6. I'm going to use the blue here. Pi over 6, and I know my sketch is not drawn to scale, but pi over 6, isn't pi over 6 located right here? Right? So that would mean that I would have a line right there. You guys with me? But then when I think about it, if this is pi over 6, isn't this 7 pi over 6? So what I'm trying to say is that these ones are representing the exact same line. Cool? Now, here in pink, 5 pi over 6 would be right here, which would be going on this direction, which will also represent what? 11 pi over 6. And lastly, pi over 2 would be this one right here, which ends up representing the 3 pi over 2. Agreed? So yes, we got 6 different angles, but they're repeating itself, and there's no need for you to repeat it. Now, I went ahead and sketched them, and now you can visually see that they are in fact tangent lines, right? But there was a second part to the definition of tangent lines at the pole. You need to make sure that what? That the derivative at that angle does not equal 0. Okay? So you must always check that. So I'm going to go here to this part of the page. Well, if f of theta is equal to 2 cosine 3 theta, so f of theta is equal to 2 cosine 3 theta, right? What is f prime of theta? Well, what's the derivative of cosine? Negative sine, and the derivative of 3 theta is going to be 3. 3 times 2 is 6 times the negative, so negative 6 sine 3 theta. Agreed? Well, now that you have the derivative, what are you going to do with it? Set it equal to 0. So negative 6 sine 3 theta equals to 0. And solve for theta. So if we divide, so that's sine 3 theta equals to 0. So 3 theta equals, where is sine 0? At 0, so 2 pi n. And at pi, right? So if I divide by 3, so theta equals 2 pi n over 3, and theta equals pi over 3 plus 2 pi n over 3. I don't need to complete this. If I start putting in numbers, do you guys see how I'm going to get pi over thirds? Which is none of the ones that I have here. Therefore, we can say tangent line pi over 6, pi over 2, and 5 pi over 6. On this example, nothing happened to repeat, but let's say that, for example, when you did the derivative, let's say that the pi over 6 showed up, then at that point, pi over 6 would not be a tangent line. Okay? It needs to pass both requirements in order for it to be a tangent line at the pole. Look, with polar, there tends to be a tendency of like one year it shows up, the next year it doesn't. I don't know. I don't know, I need to check. I'll ask. Cool? Questions about tangent lines at the pole? We're good? Alright, so that's it for this video.